Hey folks, VM Explorer here. Welcome to another session on the Home Lab Generation 7. As you know, I've evolved this generation of Home Lab for quite a while, and in this quick video we're going to be going through a quick presentation on what I did to migrate it to all-flash vSAN, which will be fun. But also at the end of this video, there will actually be some demonstration to show you how I did, what steps I did and how I took those. But just as a reminder, there was a pre-topic on this. You might check out this video here, which was upgrading and replacing the vSAN 7 cache, where I went through and actually got the cache updated first, still ran hybrid mode. And now what I'm doing is I'm changing out those hybrid or hard disks out with NVMe disks. That's this session. Okay, so quick topics, good look at the goals, some of the changes, what I did for backup and migration, how I decommissioned, how I built it, quick part list, and then really what I'm trying to get to is the very end where we'll go through some of the steps to actually implement the NVMe and get the vSAN cluster operational. Okay, so what's the kind of goal behind this? So really the goal is to migrate from a hybrid, which means like an SSD and hard disks, so that's a hybrid vSAN kind of mode, into an all-flash. Now all-flash could be all SSD, right? It could be PCIe style storage, but in this case I'm using NVMe all-flash. But why? Why do this? So one of the things that I found with hybrid is, you know, I have a lot of extra stuff in my chassis. I've got a disk controller, and I've got cables and extra power supplies, and, you know, 2 hard disks. There's a lot there that I have to maintain as well, right? So less maintenance. I don't have to update the firmware and drivers and worry about all that stuff. It's a lot going on. And it's not bad, it works, but this is one of the benefits of doing it, is reduction, lessen the maintenance, you know, overhead on it. And usually the features, the GA, are generally available with vSAN, usually start out as all flash. You know, overall, the speed's faster with NVMe is a benefit compared to hybrid, which is spinning disk, right? Which means faster migrations, execution, etc. And then also it starts to position me kind of for that vSphere and vSAN next, right? That's what I'm kind of looking forward to, is getting into all flash, being able to take advantage of all of the different options. Now, in my Home Lab Generation Next, which would probably be 8, I would guess, right? I'm going to be targeting 4 nodes with vSAN because that'll give me erasure encoding, which is essentially RAID 5, right? So I can move things around better and have a lot more functionality, and also take advantage of a lot of the features that come out. So that's kind of why I'm doing it and the goal behind it. All right, so here's the changes. So the old layout, we were looking at simply just a NVMe 500 gig disk here, right? Those 2 terabyte hard disks with that Dell HBA330, some SAS and power cables, and then the dual card. So I'm carrying over this dual NVMe card, and I'm carrying over the 500 gig NVMe into the new layout, right? And then I'm also including 2 Supermicro NVMe cards, right? They're dual, as you can see here. This one only has 1 card in it. We'll explain that a bit. And then I'm bringing over, like I said, that dual NVMe card, which is up here. So what I did is I took a look at the layout of how the CPUs stack up to the yellow sections here, which are the actual PCIe slots. And what I decided to do was put both of my capacity 2 terabyte devices closer to the 10 gigabit card, and then my cache device, which is up here on the second CPU. So that means it has to go through the QPI back and forth to get to cache, which is fine. A lot of what's done in all flash is it doesn't necessarily need to use the cache all the time. In writes, absolutely, but reads, a lot of time it comes straight from the actual capacity, which is nice. So, and then also what's nice about this dual kind of PCIe card here is it also has a SATA. This is where you boot my ESXi host on, and it actually connects directly into the SATA port. So, but why am I using 2 Supermicro cards? These are dual cards, right? I should just put both of these NVMEs on here and this should work with it. Well, it doesn't quite work that way. And the Supermicro motherboard I have, which is an X9 generation, this particular card, though it works, it only works with 1 NVMe because the bifurcation wasn't really set up really well. It was like the first generation, and they really didn't have support for NVMe cards directly on the system board. So though they work in a slot, they only work with one card. I was hoping to put 2 cards in, but it just didn't work out. Additionally, there's a quality factor here. The Super Micro cards are higher quality. They're a little bit more expensive. These cards were about $50 a piece versus this card here, which was like about $17 or something. I did initially try some cheaper cards, and when I unpackaged them, the components were literally falling off the board, and I said, no thanks. So I went with Super Micro, and this is actually going to work out well for me, because what I plan to do is when I get into my next generation home lab, I'll have room to expand. So if I want to put another NVMe card here, or move cache down, whatever I want to do in my next generation motherboard, I'll make sure that these cards are operational with it. I'll be able to carry them forward, which is always nice. All right, so backup and migration. This is where some of the challenges began, right? I had to come up with a plan of, okay, I have an existing vSAN, it's on hybrid, how do I move it to all flash? Now, I could do that. I could literally do it live. I could put a host and evacuate all data, and then I could migrate that host to all flash devices, right? And then put it back in the cluster, then they do the next one and the next one, etc. That works. The problem is you really need 4 hosts, and I have 3. You also need to have your vCenter server not part of the cluster, which that was also a problem for me because I wanted to actually shut things down. So the plan wasn't quite working out well for a 3-node host. Now what I could do is I could put my data at risk and change the policy from FTT1 to none, and then run the risk of, I could do this live and do this migration, but if something happens to my remaining 2 hosts, I'm going to lose data, no doubt about it. I didn't want to take that risk. So what I ended up doing was I decided to use my Synology and my LOCKERSTOR to help me with that. So I backed up all the VM's data using active backup with the Synology. So it backed up all the data here first. That was step 1. Okay. Then step 2, what I did was I actually migrated all these VMs off of the vSAN cluster, which is on these hosts, down to the LOCKERSTOR 10 with iSCSI. Both of these worked pretty well. I had a little issue with active backup. Check out this Home Lab Generation 7 VM grayed out issue I had. It'll explain more on how to correct that. The LOCKERSTOR worked beautifully. I was able to connect it up with iSCSI and migrate all those VMs lab. It was great. I had one issue I had, and it's not a LOCKERSTOR problem, was I had a failed drive. It always never fails, right? You move everything somewhere, you're ready to go, and you lose a disk. So I lost the disk, and that cost me a day of time to kind of rebuild this. But I got a good backup, and I've got all my VMs running happily over here. I'm now evacuated off of vSAN. So once I'm off the existing vSAN, now it's just a matter of going through the hosts, migrating all their hardware off, and then moving them forward. All right, so this is how I decommissioned vSAN. It was a bit tricky, and it didn't follow the guides. Again, the problem is because vCenter server runs on vSAN for me. I don't have it external to it. So I kind of had to figure out how to do that, because all the instructions kind of inherently think that you're running vSAN, but vCenter server's not on it. So this is how I did it. I went ahead and turned off DRS. The next step 2, I turn off vSAN. I created a new data center. Okay, you got your existing data center with your 3 hosts in it. Created a new data center. Okay, then I migrated, put a host in maintenance mode, and I moved that host to the new cluster, a new data center I just created. Okay, I then migrated Active Directory and VCSA to the new cluster, right? So it's running on vSAN right now. So I had to migrate it to the new cluster where that one host is, so I could keep up and running. Now remember, AD and VCSA are on the LOCKERSTOR, right, through iSCSI. That's good to go. And then I did basically repeated this process, put the host in maintenance mode, and moved each host into the new cluster. At that point, I deleted the old cluster. The old vSAN cluster was gone. Okay, so I migrate everything into a new cluster. vSAN's gone. The data store, vSAN data store, hung out for a little bit, but then eventually it realized that it was completely gone, and it just vanished. So that was the way that I decommissioned vSAN with an integrated VCSA. You kind of had to do it through a step migration, right? And once I did these steps, and this took me a little while to kind of poke around and kind of figure it out, it worked out properly. Now that's why I kind of thought, well, my next generation, I'm hoping to get 4 nodes, and then I won't really have as much trouble with doing all these extra backup steps and extra migration steps, decommissioning, etc. It'll give me some more flexibility where I didn't have that before. All right, this part wasn't too difficult. If you're familiar with how to build a vSAN cluster, maybe you've done it in your own home lab, or you've done it in hands-on labs, things like that. It's pretty similar. However, I did some different changes because I'm actually changing out hardware, right? Remember, the state we're in right now is we have the hosts kind of shut down and in maintenance mode, and all the old hardware is still in there. So once they're shut down, I go ahead and remove the old hardware. That's the controller card, cables, power, connectors, hard disk, all that type of stuff. That all comes out, right? Once that's removed, we power up the host, and I do that just to allow to see if the ESXi has recognized the hardware removal. Allow it to give it some time to see that, hey, look, everything's out. Once it's been powered up, then I put it in maintenance mode again, power it back down. Okay. Now I add in the new hardware. Once the new hardware is in, we boot ESXi, confirm it, and exit maintenance mode. From there, it's just basic steps such as creating the new vSAN cluster and migrating those VMs off of the iSCSI into vSAN, and we're good to go. All right, so parts lists. Went with the Supermicro AOC SLG3 2M2. You can find that out there. So I put 2 of those in each server. I put 2 of the Sabrent Rocket NVMEs. These are TLC based, which is nice. And they had a really good wear leveling technology, trim and unmap. I mean, they had all the bells and whistles. They looked really good. Already installed, as you know, from the previous video, we did the 512 version of this as well. This is for cache, and then I, of course, that card. Now, some other helpful links, and I'll put these in the description below. Some more about bifurcation and how it works, the actual motherboard, the user's manuals, different things like that. So with that, let's go ahead and transition into the actual part where we build out the new vSAN. All right, so we're looking at 3 different hosts here. We have ESXi 101, then 102, and 103. Only host 101 has had the new hardware added to it. So we went through that process where we shut it down. I removed the old hardware out. I brought it up, made sure it was gone, and then brought it back down, added the new hardware, and brought it up. I know that was a lot of thinking, right? But this is the state it's in right now, is it's ready to be added to the vSAN cluster. So let's go take a look at storage, okay? And we can see right away, let's sort by capacity. We can see right away that there's the Sabrents. There's those 2 terabyte, right? Drives that I added. This one has an extra SATA disk that I used in here that's similar in size. I just use that for extra storage. And then right above it is the other Sabrent, the 512, is 476, whatever they want to call it, right? Boot we're going to be using for cache. So that's good. Everything's here. If you take a quick look at adapters, you can see right here that Supermicro is coming out as an E12 NVMe controller. You can also see that it has the standard driver that VMware provides for NVMe PCIe driver it's using. So this host is ready to go. As far as I can tell, it's confirmed, it's ready to go. So now what I'm going to do is I'm going to go to host 102, 103, remove their hardware, add the new hardware, and then we'll get VCSA powered up. And when we come back, we'll start going through the process of building out that all-flash vSAN. All right, so one item I decided to implement based on the guidance of the Supermicro guide for the NVMe card was changing the bifurcation to the 4x by 4 basically right here, right? So if you remember from the diagram before, we chose slot 2 and slot 6 aligned well to the CPUs. And all I had to do is go in here and change this. This is in the advanced configuration for the North Bridge, drill down into slot 2. You can see it right here, Gen 3, and it's PCI per port for 4x, and then slot 6, the quad 4x. I don't know how else to say that except for saying X4 multiple times, right? So make these 2 changes right here, and that aligns to their guidance. The only thing in their guidance that this system board doesn't have is NVMe support. And that's why we can't see both NVMe sticks in the same card. Okay, so when I come back, I'll have these BIOS systems adjusted, and we'll be getting into the VCSA and getting things configured. All right, we're at the final part of getting vSAN set back up. So as you can see, I've booted 3 hosts. They're all operational. I've also got my VCSA up and running, which I'm in right now. Active Directory is up and running, and these are all running on that LOCKERSTOR 10 through iSCSI right now. But now what I want to do is establish the vSAN cluster. So the first thing I like to do is always go into administration, right? And when you're in administration, look at licenses and make sure you have a valid vSAN license. That's always step 1. Now I'm going to assume that if you're setting up vSAN for the first time, you need to read the requirements. Go to the VMware documentation and make sure you got everything figured out. I've already got this all figured out because I'm reestablishing a vSAN cluster, like DNS names and hookup and 10 gig networks, etc., etc. It's all done. All I got to do is reestablish vSAN at this point in this process, and that's what I'm going to do right now. So if I click on the cluster, configure vSAN services, it's as simple as clicking on configure vSAN. Okay, so I'm going to hit next. Done. And claim disks. Now, here's where something can hang you up. Always, when you have a chance, always go back and erase the partitions on the disks before you use them, especially ones that have been used before. You want to clear out those partitions. If you don't, they may not appear here. Once this starts up, I'll show you exactly where I'm talking about. But for now, is that it looks like it's working well. Look, it's picked out the 512 is the cache tier we wanted, and then it also picked out the 2 terabyte as the capacity tier, recognizes both as flash. That's what I'm looking for. Click on next. Review the settings. Everything looks good. Hit finish. All right, it's going to start going through its process and getting vSAN going. While it's doing that, let me show you how to clear out those partitions. Click on the host. Okay, click on storage devices. In this case, I clicked on name and sorted by the name of the device. And you can see I've got the 3 devices right here. Once those 3 are selected, I simply click on erase partitions and it erases those partitions. That's a step you want to do before you enable vSAN. It clears out all the partitions and stuff, and vSAN can see them properly when it starts building out the cluster. I'm going to let this process go ahead and finish here, and when it gets done, we'll go and review the vSAN cluster and we'll wrap this up. All right, the vSAN is now complete. We can kind of confirm that by going down and seeing that a few things have changed. You'll see there's more information here. Before we just had services, now we have disk management, fault domains, etc., whatever we need to configure, right? So everything's in a healthy state. That's what also I'm looking for before I start migrating data back to this vSAN. So far, so good. I also just kind of like to come in here and just make sure that this actually shows up. We're seeing the space we expected, which is about 11 terabytes. That looks good. Everything else, there's not much more to configure here once it's up and running for a general vSAN cluster. Now at this point, all I have to do is right-click on my VMs, be it live or be it powered off. Click migrate. I'm going to change the storage on these, and I'm going from that LOCKERSTOR 10 back into a vSAN. Now, one change I want to make sure I do is I want to make sure that I choose the correct vSAN policy, which is in this case is the vSAN default storage policy. Then I click next, finish, and that one's going to start moving back over. So folks, wrapping it up, we went through a lot of different changes here. I'm so happy to have an all-flash vSAN going now. I'll be doing more posts on performance and things like that coming up. If you have any questions, leave them in the comments below, and please do hit subscribe. Have a good day, everyone.